Hey there, truth seekers. Ever walked past an old street lamp and thought, huh, that's a weirdly fancy design for something that just holds a light bulb? Well, buckle up, because today we're about to blow the lid off one of history's most visible, yet completely ignored mysteries. Those ornate metal giants lining the streets of every old city from Paris to Melbourne aren't just pretty decorations. They're remnants of a technology so advanced, so widely distributed, and so thoroughly erased from official history that you've probably never questioned them once in your entire life. And honestly, that's exactly what someone wanted. We're talking about street lamps that showed up simultaneously across different continents before global shipping was even a thing, with identical designs, impossible engineering specs, and way too much metal for something that's supposedly just holding a gas flame. The rabbit hole goes deep. Underground foundations that reach 5 meters down when they only needed to be half a meter, copper elements on top that look suspiciously like antennas, and photographs from the 1800s showing lights so bright it would make your Ring doorbell jealous. All of this before Edison supposedly invented the light bulb. So before we dive into this conspiracy, or historical correction depending on how this goes, smash that like button if you're ready to question everything you thought you knew about street lighting, and drop a comment telling me what city you're watching from. I want to know if any of you are literally standing next to one of these mysterious metal witnesses right now. Ready to have your mind bent? Let's light this up. So let's get into the really weird part. And by weird, I mean this should be absolutely impossible, but nobody seems to notice weird. Picture this. It's the mid-1800s. There's no internet, obviously. No global supply chains. No international manufacturing standards. Heck, most countries are still figuring out if they should use the metric system or just keep measuring things in random body parts like cubits and hands. Communication between continents takes months by ship, assuming your message doesn't end up at the bottom of the Atlantic Ocean, along with your crew's hopes and dreams. And yet, somehow, impossibly, cities across the entire planet started installing virtually identical street lamps. Not similar, not inspired by, identical. The same designs, the same proportions, the same ornate details, the same mysterious copper elements perched on top like metallic crowns. Paris got them. St. Petersburg got them. New York got them. Melbourne, sitting on the literal opposite side of the world, also got them. All at roughly the same time. All looking like they rolled off the same assembly line, which technically didn't exist yet because mass production wasn't really a thing. Let me paint you a picture of how absurd this is. Imagine if tomorrow someone discovered that every major city in the world, Tokyo, Lagos, Buenos Aires, Stockholm, had all simultaneously built identical public sculptures in 1847. Same height, same materials, same bizarre geometric patterns. And when you ask historians about it, they just shrug and say, oh yeah, people back then really liked that style. That's not an explanation. That's a punt. That's what we do when we don't actually know what's going on, but don't want to admit it. The official story goes something like this. Well, you see, there was this fashion for ornate street lighting, and different cities just happened to independently come up with the same designs because, you know, aesthetic trends traveled. Which would be a great explanation if we were talking about dress hemlines or hat styles. But we're not talking about fashion accessories. We're talking about massive cast iron and copper constructions that required serious engineering, significant financial investment, and specialized manufacturing capabilities. You don't just casually copy a multi-ton metal structure because you saw a sketch in a magazine that took 6 months to arrive by boat. Let's start with Paris, because of course we're starting with Paris. The French capital installed its elaborate street lighting system in the 1840s and 1850s. Beautiful stuff. Ornate cast iron poles with intricate floral patterns, crowned with these distinctive lamp housings and topped with copper finials that supposedly serve no purpose except looking fancy. Except here's the thing. Those finials aren't decorative. They're weirdly specific. Multiple points, arranged in precise geometric patterns, always oriented in particular directions. And they're made of copper, which is an excellent conductor of electricity. Though allegedly these lamps were just burning gas at the time, so why bother with conductive metal on top? Aesthetic choice? Really? Now let's hop over to St. Petersburg. Different country, different culture, different language, different climate. You'd think they'd design their street lighting differently, right? Wrong. The lamps that went up in St. Petersburg in the same time period look like they were ordered from the same cosmic catalog as the Parisian ones. Same basic structure, same proportions, same copper elements on top. The Russian winter is brutal, by the way. Temperatures that'll freeze your enthusiasm for outdoor activities solid. Yet these lamps were built to withstand it, with the exact same engineering principles being used in the relatively mild Parisian climate. That's not adaptation to local conditions. That's following a template. Cross the Atlantic to New York, where they were installing their own version of these mysterious lamps in the 1850s and 1860s. And would you be shocked, I tell you, to learn that they look remarkably similar to their European cousins? Same general design philosophy, same copper crowns, same overbuilt construction. This is during a period when New York was still figuring out basic urban infrastructure, when most streets were dirt or cobblestone, when the city's idea of waste management was, throw it in the street and hope it rains. But somehow they had the technical specifications for street lamps that matched a global standard that officially didn't exist. Then there's Melbourne, Australia, about as far from Europe as you can get without leaving the planet. A city that was barely established in the 1830s and 1840s, growing rapidly because of the gold rush, more concerned with not dying of dysentery than with aesthetic urban planning. And yet, by the 1860s, Melbourne had ornate street lamps that would look perfectly at home on a Parisian boulevard. Same designs, same construction methods, same unnecessary complexity for what's supposedly just a gas lamp on a stick. Here's where it gets really fun. When you start comparing photographs and technical drawings from these different cities, the similarities aren't just superficial. We're talking about identical specifications. The height of the poles? Consistently between 4 and 5 meters. The diameter of the base? Usually around 15 to 20 centimeters. The internal hollow structure? Always present, always with the same general proportions. The copper elements on top? Virtually interchangeable between cities. This isn't like how McDonald's restaurants look similar worldwide. That's deliberate corporate branding with modern logistics. This is happening in an era when getting a letter from one continent to another was an achievement worth celebrating. Let's talk about the manufacturing challenge, because this is where the official explanation really falls apart. Cast iron work in the mid-1800s was not a simple affair. You needed specialized foundries, skilled metalworkers, precise molds, and quality control that was honestly pretty hit or miss. Different foundries had different techniques, different impurities in their iron, different traditions of craftsmanship. You can usually tell where a piece of 19th century metalwork came from based on these distinctive characteristics. Except with these street lamps. They're remarkably uniform across vast distances. It's like someone handed out a master blueprint and said, make it exactly like this, no variations allowed. And before you say, well, maybe one company was shipping these things worldwide, let me stop you right there. First, we have records of local manufacturing in most of these cities. The lamps weren't being imported from one central factory. They were being made locally. Second, shipping multi-ton cast iron structures across oceans in the 1840s and 1850s was expensive and risky. These weren't luxury goods, they were municipal infrastructure. Cities had every incentive to manufacture locally. Third, there's no record of any single company or organization coordinating this global rollout. No invoices, no contracts, no letters of correspondence. Just a mysterious synchronization of design and implementation. The timing is suspicious too. We're not talking about a gradual spread of technology over decades, where you could reasonably argue that ideas migrated from place to place. We're talking about a roughly 20-year window when cities across the globe decided, apparently independently, to install virtually identical infrastructure. Paris in the 1840s, St. Petersburg in the 1840s and 1850s, New York in the 1850s and 1860s, Melbourne in the 1860s, other cities falling into similar timeframes. This is coordinated rollout behavior, not organic technological diffusion. Consider what communication and transportation looked like in this period. Sending a message from Paris to New York meant putting it on a ship that would take 2 to 3 weeks to cross the Atlantic, assuming good weather and that the ship didn't sink. Getting information to Melbourne from Europe meant a journey of several months. There was no telegraph cable across the Atlantic until 1858, and even then, it was unreliable and kept breaking. The first successful transatlantic cable wasn't operational until 1866. So how exactly were these cities coordinating their street lamp specifications in real time? The answer historians give you is essentially, they weren't coordinating, they just happened to have similar ideas. Which is like saying that 10 people in different countries all simultaneously wrote the same novel by coincidence. It's technically possible in a infinite monkeys with infinite typewriters sort of way. But it's not likely. It's not reasonable. And it doesn't match how technology actually spreads. When new technologies or design innovations actually do spread organically, they show variation. They adapt to local materials, local aesthetics, local needs. Japanese architecture that borrowed from Chinese styles didn't look identical to Chinese architecture. It evolved distinct characteristics. American buildings inspired by European designs developed their own flavor. That's how cultural and technological exchange actually works. You take an idea, you make it your own, you adapt it to what you have available. You don't replicate it exactly across thousands of miles with no communication infrastructure. But these street lamps? Carbon copies. It's like someone hit copy and paste on urban infrastructure before computers existed. The level of standardization is what you'd expect from a modern international organization, with satellites and video calls and project management software. Not from a pre-industrial world where the fastest way to send a message was to give it to a guy on a horse and hope he didn't get robbed or eaten by wolves. Let's dig into some specific examples of these suspicious similarities. The base plates. These are the foundations that the lamp poles sit on, usually embedded in concrete or stone. In Paris, they used a particular pattern of bolt holes, 8 holes arranged in a specific circular pattern. Guess what shows up in New York? Same pattern, same number of holes, same radius. St. Petersburg? Identical. These aren't approximate similarities. These are exact matches. Someone, somewhere, had standardized specifications, and everyone was following them. The internal structure of the poles is even more telling. These aren't solid posts, they're hollow, with ventilation channels and internal compartments that supposedly allowed gas to flow to the lamp at the top. Except the interior design is way more complex than necessary for just gas delivery. There are baffles, chambers, multiple channels, all arranged in specific geometric patterns. And these internal features are consistent across cities. We know this because some of these lamps have been cut open or examined during restoration work, and the interiors match. Not approximately, match. Like they were built from the same technical drawings. Then there's the copper work on top. These finials, these decorative elements that sit at the highest point of each lamp. They're not random artistic flourishes. They follow specific geometric principles. Often they're composed of multiple spikes or points, arranged symmetrically, usually in configurations of 4, 6, or 8 points. Sometimes they're spheres with radiating elements. Sometimes they're more complex star patterns. But within each style, they're remarkably consistent across continents. A 6-pointed star finial from Paris looks identical to one from New York. The dimensions match. The angles match. The materials match. And here's something interesting that official histories breeze past. These copper elements on top are often described in historical documents as lightning rods or decorative finials. Except they're not positioned like lightning rods. Traditional lightning rods need to be the highest point and directly grounded. These decorative elements are often insulated from direct ground contact by the lamp housing itself. So what exactly were they for? The more you look at photographs and technical drawings from this era, the more obvious it becomes that we're dealing with a unified system. Not a coincidence, not parallel development, a system. Something that was planned, coordinated, and implemented on a scale that shouldn't have been possible with the technology officially available at the time. Now, you might be thinking, okay, but maybe there was some international organization or trade group that standardized street lighting designs and we just don't have records of it. Fair thought. Except we have pretty good records of 19th century trade organizations, international expositions, professional societies, and industrial standards groups. They loved documenting things. They loved publishing proceedings in pamphlets and trade journals. And nowhere in all of that documentation is there any mention of a global street lighting standards committee. The International Electrotechnical Commission, which actually does coordinate electrical standards, wasn't founded until 1906, way after these lamps were already installed everywhere. You know what else is weird? The maintenance records. Cities kept detailed logs of street lighting maintenance, when lamps were cleaned, when components were replaced, which workers did what tasks. And buried in these mundane municipal documents are some fascinating details. Workers described the lamps as having features they didn't understand. Components that seemed to serve no purpose for gas lighting. Instructions that got passed down without explanation. Always reconnect these wires in this specific order, or never remove the copper element during cleaning, or maintain this exact distance between lamps. Instructions that suggest these devices had functions beyond just holding a flame. There are also consistent reports across different cities of lamps that occasionally malfunctioned in identical ways. Workers would describe lights flickering in synchronization, or entire rows of lamps going out simultaneously when one failed. This is weird behavior for gas lamps, which should be independent of each other. If one gas lamp goes out, there's no reason for others down the street to react. They're not connected. But the reports suggest they were connected, somehow, in ways the maintenance workers didn't fully understand. The really damning evidence is architectural. These lamps weren't installed randomly. They followed precise spacing patterns. In Paris, the standard spacing was roughly 40 meters between lamps. In New York, it was approximately 40 meters. St. Petersburg? You guessed it, around 40 meters. This is before international metric standards. France was using meters, sure. But New York was officially using feet, and 40 meters is a really awkward number in feet. About 131 feet. If American cities were designing their own systems, they'd have used round numbers in their own measurement system. But they didn't. They used a spacing that only makes sense in meters, suggesting they were following plans created elsewhere. The alignment patterns are even more suspicious. Lamps weren't just placed at regular intervals along streets. In many cities, they formed geometric grids that extended across entire districts. When you map out the lamp positions on period city plans, you can see deliberate patterns. Straight lines connecting multiple lamps, intersections forming specific angles, arrangements that create geometric shapes. This goes way beyond "we need to light the streets." This is precision placement for some other purpose. And here's the kicker. When cities decided to modernize their street lighting in the early 20th century and replace these old lamps with electric ones, they often kept the exact same pole positions. The new electric lamps went exactly where the old ones had been. Why? If you're redesigning your lighting system with new technology, this is your chance to optimize placement for actual illumination needs. But instead, they preserved these specific geometric arrangements, as if the positions themselves were important for reasons beyond just lighting. Cross-reference all of this with the timeline of industrialization, and you notice something else strange. These elaborate lamp systems appeared in cities before those cities had the industrial capacity to manufacture them. Melbourne in the 1860s was still a frontier city by European standards, yet they had street lamps with manufacturing quality that matched London or Paris. New York's foundry capabilities in the 1850s were good, but not exceptional. Yet they produced lamps with specifications identical to European standards. It's like someone with advanced manufacturing gave everyone the same product, then everyone pretended they made it themselves. The photographs from this era tell their own story. When you look at early images of major cities from the 1860s, 1870s, and 1880s, the street lamps are always prominently featured. They're in the center of the frame, they're clearly important to the composition, they're shown in detail. Photographers went out of their way to include them. And when you compare these photos across different cities, you see the same visual language. Lamps as focal points, careful attention to their details, almost like they're documenting something important. Something that people in that era understood was significant, even if later generations forgot. There are also these tantalizing hints in period literature and newspapers, occasional mentions of street lamps doing odd things, lights that seemed too bright for gas flames, reports of strange humming sounds near lampposts during certain weather conditions, observations that lamps seem to work better or worse depending on atmospheric conditions, which makes sense for gas lamps only if you assume gas pressure is affected by weather. But the effects described are way more dramatic than that would. Explain. These are buried in local newspapers, in letters to the editor, in journal entries. Little breadcrumbs suggesting people noticed something unusual but couldn't quite articulate what it was. The construction patents from this period are equally revealing. When inventors filed patents for street lamp designs, they often included features that seem unnecessary for gas lighting. Multiple internal chambers. Copper components, specifically described as resonant elements. Precise specifications for the height and positioning of various parts. Instructions for underground installations that go way deeper than gas pipes needed to be. Read these patents with modern eyes, and they sound less like gas lamp designs and more like descriptions of electrical or electromagnetic devices. And speaking of underground, We need to talk about what's beneath these lamps, because that's where things get really interesting. But I'm going to need a whole other section for that, because the rabbit hole literally goes underground. For now, just sit with this. Across the entire globe, in an era when international coordination should have been nearly impossible, cities installed identical infrastructure following specifications that nobody will admit to coordinating. This wasn't fashion. This wasn't coincidence. This was a system, a big one, a global one. And somebody went to great lengths to make us all forget it existed. The question isn't whether this is weird. It's definitely weird. The question is, what exactly was this system for? Who built it? And why did someone work so hard to erase it from history? Keep those questions in mind, because we're about to go deeper, metaphorically and literally. Next up, what's hiding under the streets? And why do these lampposts need foundations that go down 5 meters when a gas pipe only needs half a meter? Spoiler alert, the official explanation makes 0 sense, and the alternative is absolutely wild. All right, let's get technical. And by technical, I mean grab a magnifying glass and start looking at these street lamps like they're crime scene evidence technical. Because once you actually examine what these things are made of and how they're constructed, the official story about them being simple gas lamps falls apart faster than a conspiracy theorist's credibility at a family dinner. Let's start with the basics. Wall thickness. Your average gas lamp from the 19th century, the ones that were genuinely just meant to hold a flame, had relatively thin metal walls. Makes sense, right? You need a pipe to deliver gas, a housing to protect the flame from wind, and that's about it. Thin walls are cheaper, lighter, easier to manufacture, and perfectly adequate for the job. But these ornate city lamps we're talking about, they've got walls that are anywhere from 5 to 12 millimeters thick. That's not adequate for the job. That's preparing for a siege. To put this in perspective, modern streetlight poles, the ones designed to withstand car impacts, extreme weather, and the occasional drunk driver using them as a brake test, have walls around 3 to 5 millimeters thick. These 19th century gas lamps are built twice as thick as modern steel poles that have to meet actual engineering safety standards. Why? The official explanation is usually something vague about durability or aesthetic preferences for heavier construction, which is historian speak for, we have no idea, but we're not going to admit it. Here's the thing about over-engineering. It costs money. A lot of money. Cast iron in the 1850s wasn't cheap. Manufacturing thick-walled structures required more material, more time, more skilled labor, and more quality control. Cities were penny-pinching even back then. Municipal budgets have never been generous, and councils have always loved cutting corners wherever possible. So why would they spend extra money making lampposts that are dramatically overbuilt for holding a gas flame? That's like buying a monster truck to drive to the grocery store. Sure, you could do it, but why would you? Now let's talk about what's inside these poles, because this is where things get really interesting. These aren't solid metal posts. They're hollow, which makes sense. You need space for the gas line to run up to the lamp. But here's what doesn't make sense. The interior isn't just a simple hollow tube. It's divided into multiple chambers. There are baffles, partitions, separate channels running parallel to each other, and ventilation systems that are way more complex than necessary for just moving gas from point A to point B. Pull up any surviving technical diagram from this era, and there are plenty in municipal archives and patent offices, and you'll see cross-sections that look less like gas lamp designs and more like some kind of Tesla coil blueprint. Multiple concentric layers, isolated channels, chambers within chambers, air gaps with specific spacing. It's the kind of internal complexity you'd expect from a device that needs to manage multiple functions simultaneously, not from a pipe that just carries flammable gas. The ventilation systems are particularly suspicious. Gas lamps do need ventilation. You're burning fuel, you need oxygen. You need to let combustion byproducts escape. But a simple vent at the top and maybe some air intake holes at the bottom would do the job just fine. Instead, these lamps have elaborate ventilation networks with multiple channels, directional vents, and carefully calculated airflow paths. Some designs include horizontal vents arranged in specific patterns around the circumference of the pole. Others have spiral ventilation channels that wrap around the interior. This is aerospace-level engineering for what's supposedly a Victorian-era lantern on a stick. And then there are the copper elements on top. We touched on these earlier, but let's really dig into them now. Copper is expensive. It's always been expensive. It's also heavy, requires specialized metalworking, and corrodes faster than iron or steel in outdoor conditions. So why put copper components on top of every single one of these lamps? The decorative argument doesn't hold up. You could make something that looks just as fancy out of cheaper metals. The lightning rod explanation is inconsistent with how they're actually installed. So what's the real reason? Here's a hint. Copper is an excellent electrical conductor. It's the second best common metal for conducting electricity, right after silver. If you were designing a device that needed to collect, transmit, or resonate with electromagnetic energy, copper would be your material of choice. And the positioning of these copper elements, always at the highest point, often in configurations that maximize surface area, suggests they're meant to interact with something in the atmosphere above them. The geometric patterns of these copper finials are worth examining too. They're not random decorative flourishes. They follow specific mathematical principles. Multiple points arranged in symmetrical patterns, 4-point, 6-point, 8-point configurations being most common. These geometries show up repeatedly in electromagnetic and resonance applications. Tesla's patents from the 1890s and early 1900s, for example, use similar geometric arrangements for his wireless energy transmission designs. Except these lamp finials predate Tesla's patents by decades. So either street lamp decorators accidentally stumbled upon optimal electromagnetic geometries through aesthetic choices, or these things were designed with electromagnetic principles in mind from the start. Let's look at some actual patents from this period, because this is where the contradictions become impossible to ignore. There's a patent filed in New York in 1856 for a street lamp illumination system that describes in careful detail a hollow cast iron pole with internal resonance chambers and a copper crown piece designed to facilitate atmospheric conductivity. Read that again. Atmospheric conductivity for a gas lamp. That's like finding a patent for a horse-drawn carriage that includes specifications for a catalytic converter. It doesn't make sense unless the device was meant to do something other than what it's officially claimed to do. Another patent from London, dated 1862, describes a street lamp with grounding plates to be installed at significant depth and copper terminals arranged to maximize surface contact with atmospheric conditions. The patent explicitly states these features are essential to proper function, but never explains why a gas lamp would need grounding plates or atmospheric contact optimization. Gas doesn't care about being grounded. Fire doesn't need to optimize atmospheric surface contact. These are specifications for an electrical or electromagnetic device. Here's my favorite part. Some of these patents include electrical resistance calculations, actual ohm measurements for different components, material conductivity specifications, design notes about minimizing electrical interference between components. All of this appears in documents supposedly describing gas-powered street lighting. It's like finding a cookbook from 1860 that includes detailed instructions for programming your microwave. The technology being described doesn't match the era it's supposedly from. The material specifications get even weirder when you dig into them. These lamps weren't made from standard cast iron. Analysis of surviving specimens shows they used specific alloys with carefully controlled composition. Higher carbon content than typical cast iron. Trace amounts of copper and other metals mixed in. Controlled cooling processes to achieve particular crystalline structures. This is precision metallurgy that supposedly wasn't common practice until decades later. And the machining quality is suspiciously advanced. Threads for connecting components are cut with remarkable precision. Mating surfaces are smoothed to tolerances that would be impressive even by modern standards. Internal surfaces show evidence of finishing processes that weren't supposed to be standard practice in the mid-1800s. Someone was investing serious effort into manufacturing quality that goes way beyond what gas lamp duty would require. The lamp housings themselves, the glass enclosures that supposedly protected the gas flame, have their own peculiarities. The glass used isn't standard window glass. It's often specially formulated with particular optical properties. Some examples show evidence of metallic coatings on the interior surface, which makes zero sense for a gas lamp, but would be useful for containing or directing certain types of electromagnetic radiation. The shapes of these housings follow specific geometric principles too, often spherical or designed to focus light in particular ways that are unnecessarily complex for just diffusing gas flame illumination. Now here's where it gets really technical, so stay with me. The spacing between components in these lamps follows mathematical ratios that show up in resonance and wave theory. The distance from the base to the first junction point, the height of internal chambers, the spacing of ventilation holes. These aren't random measurements. They're multiples of specific wavelengths. Someone sat down with physics calculations and engineered these things to resonate at particular frequencies. This is not how you design a gas lamp. This is how you design an antenna or a resonator. There are also consistent reports in maintenance logs of lamps behaving in ways that don't make sense for gas lighting. Workers describe synchronization effects, one lamp's behavior affecting others nearby. Descriptions of lights that seem to pulse or vary in intensity in ways that gas flames shouldn't. Reports of electrical sensations when touching certain parts of the poles during specific weather conditions. These aren't isolated incidents. They show up in municipal records from multiple cities, described by different workers who had no contact with each other. The construction methodology is another red flag. These lamps were assembled using techniques that were surprisingly modular for the era. Components were interchangeable between units. Replacement parts from one manufacturer would fit lamps made by different manufacturers. There was a level of standardization that suggests someone was thinking about maintenance and long-term operation on a system-wide scale. This is modern thinking, designing for serviceability and standardized components. It's not how things were typically built in the mid-1800s, when most manufacturing was still semi-custom and parts rarely interchanged between different makers. Let me paint you a picture of what's actually required to make one of these things. You need a foundry capable of casting complex, thick-walled components with internal features. You need metal workers who can machine threads and mating surfaces to tight tolerances. You need glass makers who can produce specialized optical components. You need copper workers who can fabricate intricate geometric structures. You need engineers who understand materials science, structural design, and apparently electromagnetic theory. And all of this has to come together to build what's officially just a fancy way to hold a gas flame. It's like if someone in 1850 asked you to build a really nice candle holder and handed you specifications that required a machine shop, a chemistry lab, and a particle accelerator. The complexity of the ask doesn't match the simplicity of the supposed function. But wait, there's more. And by more, I mean a whole secret world buried under your feet that nobody wants to talk about. Because the real crazy part of this street lamp mystery isn't what you can see above ground. It's what's hidden below it. And friends, what's below it makes the surface-level weirdness look absolutely rational by comparison. Let's start with a simple question. How deep does a gas pipe need to be buried? The answer, according to every engineering manual from the 19th century to today, is roughly 30 to 60 centimeters. About a foot to 2 feet, for those of you still using Freedom units. That's deep enough to protect the pipe from surface damage, frost heaving, and accidental digging. Go deeper than that and you're just wasting money on excavation for no benefit. Gas pipes don't care how deep they are. They work just fine at shallow depths. So explain to me why the foundations for these street lamps routinely go down 3 to 5 meters. That's 10 to 16 feet deep. That's basement level depth. That's, you've accidentally hit an underground spring and now your excavation is a swimming pool depth. And yet, municipal records from cities across the globe show this kind of foundation depth as standard practice for street lamp installation. Not occasionally, not in special cases. Standard practice. New York's Department of Public Works has archived installation reports from the 1850s describing lamppost foundations that required excavations of 15 feet or more. Paris municipal records from the 1840s specify minimum foundation depths of 4 meters. St. Petersburg's city planning documents from the same period mandate similar depths. Melbourne, London, Philadelphia, they all have records of street lamp installations that involved digging way, way deeper than gas pipe installation would ever justify. The official explanations vary by city, but generally boil down to structural stability or preventing toppling in high winds. Which would be a reasonable explanation if we were talking about massive structures. But we're talking about cast iron poles that are maybe 5 meters tall and weigh a few hundred kilograms. The physics of structural stability don't require a 5-meter deep foundation for that. Modern streetlights, which are often taller and have to withstand actual engineering loads like hanging traffic signals, use foundations that are maybe a meter deep at most. So why were 19th century cities over-engineering their foundations by factors of 3 to 5 times what structural requirements demand? Here's where it gets interesting. When excavations for modern construction projects dig up old street lamp foundations, which happens reasonably often in historic city centers, they find things that don't match the official story. Instead of simple concrete piers or stone footings, they find elaborate underground structures, chambers, voids, Compartments, things that look more like wells or cisterns than lamppost foundations. There are documented cases of construction crews in Paris uncovering old lamp foundations that included brick-lined chambers large enough for a person to stand in. Not occasionally, multiple times, in different parts of the city. Similar discoveries have been made in London, New York, and other cities that had early street lamp systems. These aren't foundation piers. These are underground rooms built specifically in connection with street lamp installations. Now, you might be thinking, okay, maybe they used those chambers for storing maintenance equipment or as access points for gas workers. Reasonable guess. Except, these chambers aren't connected to the surface in ways that would make that practical. They're sealed. Access would require digging down from street level each time, which defeats the purpose of having a chamber. And the interior features of these spaces, when they've been examined, include elements that make no sense for storage or access. Technical reports from municipal archives describe underground lamp installations with copper plate foundations and isolated conductor channels. Let me translate that. They built these foundations with large copper plates embedded in the base and installed insulated channels, basically early cable conduits, running from the chamber to the lamp post above. Why would a gas lamp need copper grounding plates? Why would it need insulated conductor channels? Copper and insulation are for electrical systems, not gas systems. Some of the most detailed documentation comes from Philadelphia, which kept meticulous records of its 1850s street lamp installation project. The reports describe foundations that included metallic grounding matrices extending outward from the central pier, with copper plates arranged in geometric patterns underground. The specifications call for these plates to be connected to the lamppost base via thick copper cables that were, notably, insulated with gutta percha, one of the only good electrical insulators available in that era. Gas pipes don't need insulation. Electrical conductors do. The depth of these installations correlates with something else interesting: groundwater level. In many cities, the foundation depth for lamps consistently extends to just below the local water table. This is significant because electrical grounding is much more effective when it reaches moist earth or groundwater. If you were designing a system that needed to exchange electrical charge with the earth itself, you'd want your ground connection at or below the water table. But if you're just installing a gas lamp, who cares about the water table? The gas certainly doesn't. Let's talk about the underground networks connecting these lamp foundations, because this is where things go from suspicious to undeniable. When cities have done archaeological surveys or utility mapping in historic districts, they've discovered that the old lamp foundations were connected by underground channels. Not gas lines. Those are different and usually shallower. These are separate channels, often lined with insulating materials, running from lamp to lamp beneath the streets. London's sewer system renovation projects in the 1990s and 2000s uncovered multiple examples of these interconnected lamp foundation systems. The channels were too large to be gas pipes, typically 15 to 20 centimeters in diameter, and they included features like inspection chambers and junction boxes at regular intervals. The insulation materials used were consistent with early electrical insulation, not gas pipe wrapping. And the routing of these channels often didn't follow the most direct path between lamps, instead following geometric patterns that suggest they were part of a designed network topology. What's really telling is that these underground channels were carefully sealed and protected. Gas pipes from that era were typically just iron pipe buried in earth, maybe wrapped with tar paper if someone was feeling fancy. But these lamp foundation channels were built like they were meant to last and meant to protect whatever was inside them. Brick channels, clay pipe conduits, insulating wrappings, multiple layers of protection. This is how you build infrastructure you care about, not how you casually run a gas line. The junction chambers are particularly fascinating. At intersections where multiple lamp lines met, there would be larger underground chambers with multiple channels entering and exiting. Inside these chambers, workers found evidence of metal fixtures, ceramic insulators, and cable management structures. Again, this is electrical infrastructure vocabulary, not gas system components. Some of these junction chambers had ventilation shafts that extended to the surface, which would make sense for electrical equipment that might generate heat or gas, but makes no sense for a gas distribution system that already has ventilation at street level through the lamp itself. There are also consistent reports of unusual materials found in these underground installations. Ceramic components that look suspiciously like electrical insulators, glass elements that may have been primitive vacuum tubes or sealed chambers, metal plates arranged in layered configurations that resemble early capacitor designs, None of this belongs in a gas lighting system. All of it would make sense in an electrical or electromagnetic energy system. Municipal engineers who've examined these underground structures usually describe them as unexplained historical infrastructure and move on. Nobody wants to be the person who suggests that cities in the 1850s were building something that shouldn't have been technologically possible. It's easier to just document the findings, note that they're weird, and let future generations worry about explaining it. The maintenance costs for these deep foundations were substantial, by the way. City budgets from the period show significant expenses for lamp foundation maintenance, way more than you'd expect for simple support. There are records of specialized workers whose job was specifically to maintain the underground portions of the lamp system. Not gas fitters, not general laborers. Specialized technicians who apparently needed specific training for whatever was down there. Their job descriptions include phrases like maintaining underground conductivity and servicing foundation matrices, which are strange terms to use for what's supposedly just the base of a gas lamp. Here's something that should blow your mind. Some of these underground structures show evidence of water management systems. Not drainage, deliberate water management. Channels designed to maintain specific moisture levels in the soil around the foundations. Ceramic pipes that seem designed to deliver or remove water in controlled ways. Why would the soil moisture around a lamppost foundation matter for a gas lamp? It wouldn't. But it would matter a lot for an electrical grounding system, where conductivity depends on soil moisture content. The geographic distribution of these deep foundation systems is worth noting too. They're not evenly distributed across cities. They concentrate in certain areas, often in prestigious districts, near major public buildings, along main boulevards. And the densest concentrations tend to be in locations that later became centers of early electrical infrastructure. Coincidence? Maybe. But it's a pretty specific coincidence that the areas with the most elaborate underground lamp infrastructure also happen to be where cities later built their first electrical substations and transformer facilities. When cities began replacing these old lamp systems with modern electric street lighting in the early 1900s, there was a curious pattern in how they handled the old foundations. In most cases, they didn't excavate them. They just capped them off and installed new, shallower foundations for the electric lamps. This is weird because if you're doing street work anyway, removing old infrastructure would be standard practice. It prevents future complications when you inevitably need to dig there again. But instead, they sealed these underground chambers and left them in place. Almost like they wanted to preserve something, or hide evidence of something. The few times these old foundations were actually removed, the process was documented as being surprisingly difficult and expensive. Workers described structures that extended deeper than expected, with more complex construction than anticipated. There are reports of foundations that turned out to be connected to even deeper structures, tunnels, chambers, or other infrastructure that predated the lamp installation itself. This suggests the lamp system might have been built to connect with or utilize existing underground infrastructure that served some earlier purpose. There's one particularly interesting case from Boston, where a street renovation project in 1923 involved removing old street lamp foundations from the 1860s. The work crew's foreman filed a report describing what they found. Underground chambers extending 20 feet down, connected by brick-lined tunnels, with what he described as electrical fixtures of unknown origin, still in place. The city engineer's office responded by ordering the chambers filled with concrete without further investigation. The foreman's report is still in the city archives, but there's no follow-up documentation. Just a note saying, sealed as directed. This pattern repeats across multiple cities. Unusual underground structures discovered during utility work, brief documentation of something strange, then orders to seal it up and not ask questions. It's not a conspiracy when it's documented in official municipal records. It's just an organized effort to bury the evidence, literally. The soil analysis around these old lamp foundations reveals something else interesting. In multiple locations where foundations have been excavated, the soil shows anomalous mineral content, higher concentrations of certain metallic elements than would naturally occur, unusual crystalline structures in the dirt, chemical alterations consistent with long-term electrical current flow through Earth. This is evidence that these underground structures were doing something that affected the surrounding Earth at a chemical level. Gas pipes don't do that. Electrical systems do. One more thing worth mentioning, the construction timing. These elaborate underground installations were built rapidly, much faster than the complexity of the work should have allowed. Paris installed thousands of lampposts with deep foundations in just a few years. New York did similar work at a pace that seems impossible given the manual labor and limited equipment available. Either these cities had access to construction techniques we don't know about, or they were prioritizing this work at a level that doesn't match the supposed purpose of just lighting streets with gas. So here's where we are. Cities around the world built elaborate underground infrastructure nominally for gas street lighting, but with design features that only make sense for electrical systems. They used materials, techniques, and components that were completely unnecessary for gas lighting, but essential for electrical conductivity and grounding. They spent enormous amounts of money building this infrastructure to specifications that far exceeded practical requirements. And then, when they eventually replaced these systems, they went to unusual lengths to seal and hide what was underground rather than simply removing it. The surface-level lamps were weird enough, but what's under the ground is what really proves this wasn't just about lighting streets. This was infrastructure for something else entirely, something that required deep foundations, copper grounding plates, insulated channels, and network connectivity. The only question is, what exactly that something was, and why someone worked so hard to make sure we'd forget it ever existed. Next time you're walking down a street in an old city, and you see one of those ornate antique lampposts, remember, you're looking at the tip of an iceberg. Most of this mystery is underground, buried under decades of concrete and carefully orchestrated amnesia. And that's exactly where someone wanted it to stay. Now let's talk about something that should have raised red flags for historians a long time ago, but somehow gets brushed aside with hand-waving and vague technical explanations. I'm talking about those beautiful old nighttime photographs of 19th century cities. You know the ones, where streets are glowing with light, buildings are clearly visible, shadows are sharp and well-defined, and everything looks absolutely gorgeous. The only problem? Those photos are physically impossible. And I don't mean slightly exaggerated. I mean, this violates the laws of physics as we understand photography impossible. Let's start with the official story, which goes like this. These are long-exposure photographs. The photographer would set up their camera on a tripod, open the shutter for several minutes or even hours, and all that light from the gas lamps would accumulate on the photographic plate, creating a bright image. Sounds reasonable, right? Except it's complete nonsense, and anyone with basic knowledge of photography or physics should be able to see why. Here's the thing about long exposures. Yes, they accumulate light over time, but they also accumulate blur. Anything that moves during the exposure becomes a ghost or a streak. People walking by? Gone or blurred into oblivion. Horse-drawn carriages? Invisible or just streaks of motion. Trees moving in the wind? Fuzzy. Clouds? Smeared across the sky. But look at those old nighttime city photographs from the 1860s, 1870s, and 1880s, and you'll see something weird. Crisp, sharp images with minimal motion blur, shadows that are defined and directional, and light levels that suggest a much shorter exposure than the official explanation claims. Let me give you a specific example. There's a famous photograph of New York's Broadway from 1868, taken at night. The image shows the street lit up, buildings clearly visible, signs readable, and even some relatively sharp details of people and carriages. The photographer's notes claim it was a 15-minute exposure. Okay, cool. Except in 15 minutes, the Earth rotates enough that stars would show noticeable trailing in the image. People standing still for 15 minutes would blur from natural body movement. Humans can't hold perfectly still that long. Carriages that paused even briefly would leave ghost images at every position they occupied. But none of that is visible in the photograph. The image suggests an exposure time closer to a few seconds, not 15 minutes. Now you could argue that maybe the photographer lied about the exposure time. Fair point, people exaggerate their technical achievements all the time. But here's the problem. If the exposure was short enough to freeze motion like that, then the light sources would need to be incredibly bright. We're talking about light intensity that's at least 10 to 15 times stronger than what gas flames can produce. There's no way around this. The math doesn't work with gas lighting. Let's get scientific for a moment. Modern lighting engineers have done reconstructions of 19th century gas street lamps. They've built replicas using period-accurate materials and gas mixtures. They've measured the actual light output of these flames. The results? A typical gas street lamp produced somewhere between 100 and 300 candle power, depending on the quality of the gas and the burner design. To put that in modern terms, that's roughly equivalent to a 15 to 40 watt incandescent bulb. Not exactly blazing illumination, More like, you can vaguely see where you're going if you're standing directly under it, levels of light. But the photographs from this era show illumination consistent with much more powerful light sources. Photometric analysis, which measures light levels based on exposure, shadows, and contrast in photographs, suggests these street scenes had light levels comparable to early 20th century electric street lighting. That's 1,000 to 2,000 candle power or more. The discrepancy isn't small. It's not explainable by better gas or more efficient lamps. It's an order of magnitude difference that shouldn't exist. Here's another fun detail: the color quality of the light in these photographs. Early photographic emulsions were more sensitive to blue and ultraviolet light than to red and yellow. Gas flames burn primarily in the yellow, orange, red part of the spectrum. This means gas lamps should photograph relatively dimly on early photographic plates, which were blue sensitive. But the nighttime photographs we're looking at show bright, even illumination captured on these blue-sensitive plates. That's consistent with light sources that have significant blue or white spectrum components, like electric arc lights or some other high-temperature light source. It's inconsistent with yellow-orange gas flames. The shadow patterns in these photographs are particularly revealing. Shadows aren't just dark areas, they're information. The sharpness of shadow edges tells you about the size and distance of the light source. Soft shadows come from large, close light sources. Sharp shadows come from small, distant light sources or very bright, focused sources. The photographs from 1860s and 1870s cities show relatively sharp shadows, which suggests light sources that are either very bright or positioned in ways that create focused illumination. Gas flames are relatively large light sources. The visible flame spreads several inches and should create softer shadow edges. But that's not what the photos show. There are also these weird consistency issues. Photographs from different cities, taken by different photographers with different equipment, all show similar light levels and quality. This is suspicious because photographic techniques varied widely in this era. Different photographers used different chemicals, different exposure times, different development processes. Their results should vary noticeably. But the nighttime street photography from this period has a remarkable consistency in how the lighting appears. Almost like everyone was photographing the same type of light source despite officially using different technologies in different places. And then there's the matter of light distribution. Look at how evenly lit these old street scenes are. Gas lamps create pools of light with significant dark areas between them. Anyone who's seen actual gas lighting, whether in historical reconstructions or modern gas lanterns, knows that the light falls off rapidly with distance. You get bright spots directly under each lamp and progressively darker areas in between. But the photographs show much more even illumination across entire streets and plazas. The light distribution suggests either way more lamps than are visible in the photos, or light sources that spread their illumination much more effectively than gas flames can. Let me throw one more technical detail at you: reflection patterns. When light hits wet pavement, glass windows, or metal surfaces, it reflects in specific ways. The quality and intensity of these reflections tell you about the light source. Gas lamps create relatively dim, yellow-orange reflections. The nighttime photos we're examining show bright, sharp reflections that suggest higher intensity white light. Some photographs even show what appear to be specular highlights, bright pinpoint reflections that only occur with very intense light sources. Try to get that effect from a gas flame. You can't. The flame isn't intense enough, and its large size diffuses the reflection. Now here's where conspiracy theorists and historical revisionists love to jump in with wild theories about ancient advanced civilizations and lost technology. But let's stay grounded for a moment. We don't need ancient aliens to explain this. We just need to acknowledge that maybe, the official timeline of electrical street lighting is incomplete. Maybe experiments with electrical or electromagnetic lighting were happening earlier and more widely than history books admit. Maybe those copper-topped lampposts with their elaborate underground foundations were actually serving an electrical function, while gas lamps were the official story. There are historical hints that support this idea. Reports from the 1860s and 1870s of unusually bright street lighting in certain districts. Newspaper articles describing lights that seemed to flicker like lightning or glow with unnatural brilliance. These accounts get dismissed as poetic exaggeration or misunderstanding by witnesses. But what if they were accurately describing something unusual? What if some of these lamps were actually electric, powered by some experimental system, while everyone was told they were just fancy gas lamps? The timing is interesting too. The period when these impossibly bright photographs were taken, roughly 1860s through 1880s, corresponds exactly with the peak of the mysterious lamp installations we've been talking about. It's also a period of intensive but often secretive experimentation with electricity. Multiple inventors were working on electric lighting, electromagnetic systems, and power transmission. Not all of this work was publicly documented. Some of it was done under private funding or military contracts. It's entirely possible that successful electrical lighting systems were demonstrated or even deployed in limited areas, while the official narrative maintained that gas was the only option. But here's where things get really wild. And I mean, rethink everything you know about architecture wild. Those street lamps weren't isolated devices. They were nodes in a much larger system. And that system wasn't just about the lamps. It was about the entire urban landscape. The buildings themselves were part of it. Every spire, every tower, every decorative metal finial on every rooftop, every dome, every weather vane, all of it was designed using the same geometric and electromagnetic principles as the street lamps. Welcome to the concept of resonant architecture, where cities weren't just places to live but were giant machines, designed to do something we've completely forgotten about. Take a walk through any old European city or historic districts in American cities that survived urban renewal. Look up at the buildings from the 19th century. Really look at them. What do you see on the rooftops? Metal spires, decorative towers, copper domes, elaborate finials, weather vanes made of brass or copper, iron railings with specific geometric patterns. And here's the kicker. All of these architectural elements use the same design vocabulary as the street lamp finials we've been discussing. Multiple points, symmetrical arrangements, specific geometric configurations. They're not random decorative choices. They're following a template. The geometry shows up everywhere once you start looking for it. 6-pointed stars, 8-sided polygons, spiral patterns, radiating spikes arranged at precise angles. These patterns appear on lamp tops, building spires, weather vanes, balcony railings, and window grills. It's the same design language repeated across different scales and different structural elements. This is not coincidence. This is not just the style of the era. This is systematic implementation of specific geometric principles across an entire architectural ecosystem. Let's talk about building spires for a moment, because these things are everywhere in 19th century architecture, and nobody questions why. Churches have spires. Okay, that makes sense for religious symbolism, reaching toward heaven, yada yada. But why do so many secular buildings from this era have spires? Town halls, market buildings, train stations, banks, theaters, tons of civic structures that have no religious function but feature prominent spires topped with metal finials. The official explanation is usually aesthetic choice, or Gothic revival style, or some other architectural hand-waving. But look at what these spires are made of. Metal frameworks covered in metal sheathing, topped with conductive metal finials, often copper or brass, positioned at the highest point of the structure. Starting to sound familiar? Here's what's really interesting. The positioning of these architectural elements correlates with the placement of street lamps. Map out the locations of lamps in a 19th century city district. Then, map out the locations of buildings with prominent metal spires or domes. The patterns align. Buildings with the most elaborate metal-topped structures tend to cluster at intersections or along lines where multiple lamp rows converge. It's like the urban planners were creating a grid, with street lamps as the regular nodes and buildings as the major junction points. This is network topology thinking. This is how you design a distributed system with multiple types of nodes working together. The spacing relationships are mathematically precise. Measure the distance from a street lamp to the nearest building spire. Then measure the distances between spires. Then between spires and the next lamp cluster. The ratios are consistent. They follow harmonic proportions, mathematical relationships that show up in music theory, resonance physics, and wave mechanics. This isn't happy accident. Somebody calculated these positions with specific mathematical relationships in mind. The city layout itself was a geometric formula. Copper domes deserve special attention because they're everywhere in 19th century architecture, and they're wildly impractical for just about every normal architectural purpose. Copper is expensive. It's soft, so it's not particularly structural. It oxidizes quickly, turning green, which is pretty sure, but it also means you're watching your expensive building material corrode. Lead or iron would be cheaper and more durable for waterproofing a dome. But no, Cities across the world spent enormous amounts of money putting copper domes on their important buildings. Why? Because copper is an excellent electrical conductor, and if you're building a resonant electromagnetic system integrated into your architecture, copper domes at high points are exactly what you'd want. The orientation of these architectural elements matters too. Many buildings' spires and finials aren't just vertically oriented. They're angled or have multiple arms pointing in specific directions. When you map these orientations across a city, patterns emerge. Spires pointing toward each other across distances. Directional weather vanes consistently oriented along particular axes. Decorative finials with asymmetric designs all oriented the same way. This is deliberate alignment, not random decoration. Something about directionality was important to this system. Interior architecture has suspicious elements too. Metal chandeliers in public buildings from this era are way more elaborate than necessary for just holding candles or gas lamps. They're huge, made of brass or bronze, and feature intricate geometric patterns with multiple tiers and radiating arms. Look familiar? They're using the same design principles as the exterior finials and lamp tops. These weren't just lighting fixtures. They were part of the same system, positioned inside buildings at specific heights, usually in central halls or under domes. It's like the system had external components, street lamps, spires, and internal components, chandeliers, metal installations, all working together. The really creepy part is how integrated this all was into city planning. When cities were designed or redesigned in the 19th century, architectural guidelines would specify not just street widths and building heights, but also requirements for specific architectural elements. All civic buildings must feature a central tower or spire, or residential buildings above 3 stories must include decorative metal railings with approved geometric patterns. These weren't just aesthetic rules. They were ensuring that the system had the components it needed distributed throughout the urban fabric. There are documented cases of buildings being modified to add these elements when they didn't originally have them. Structures would be retrofitted with metal spires or decorative finials during the same period when street lamp systems were being installed. Sometimes the building modifications were officially justified as modernization or aesthetic improvement. But look at the timing. It's synchronized with the lamp installation schedules. The buildings were being prepared or adapted to work with the lamp network. Some of the most elaborate examples of this integrated architecture are in capital cities and major urban centers. Paris under Haussmann's renovations, Vienna's Ringstrasse development, Berlin's expansion, Washington, D.C.'s layout. All of these major 19th century urban projects involved coordinated architecture with prominent metal-topped structures and synchronized street lamp installations. The official historical narratives focus on politics, social goals, and aesthetics. But the technical synchronization of architectural and infrastructure elements suggests there was another layer to these projects that historians don't talk about. Window arrangements show patterns too. Buildings from this era often have metal window frames or metal decorative grills with specific geometric patterns. The spacing and positioning of windows relative to street lamps and building corners follows mathematical proportions. It's like every element of the building facade was positioned according to some underlying template. Modern architects study these buildings and admire their proportions without realizing that the proportions might have been calculated for electromagnetic or resonant properties, not just visual aesthetics. Even the building materials seem chosen with more than structural or aesthetic purposes in mind. The extensive use of iron frameworks, copper and brass fixtures, specific types of stone known for particular electrical properties. It's like 19th century builders had a shopping list that prioritized conductivity and electromagnetic interaction, alongside strength and durability. Why did so many buildings from this era incorporate so much metal into their structure, when earlier construction methods used primarily wood and stone? The official answer is industrialization, making metal cheaper and stronger designs possible. But maybe the metal served multiple purposes. The underground connections come back into play here too. Many major 19th century buildings have deep foundations that seem excessive for their structural needs. Sound familiar? And some of these buildings have underground connections to utility tunnels, basements, or subterranean chambers that link to the same infrastructure network as the street lamp foundations. It's all interconnected. The lamps, the buildings, the underground works, one integrated system spanning above and below ground across entire city districts. What was this system supposed to do? That's the billion-dollar question. If you believe the conspiracy theorists, it was for free energy distribution. atmospheric electricity harvesting, or some kind of wireless power transmission. If you're more conservative, maybe it was just very early, very experimental electrical systems that predated Edison's grid. Or maybe it was for something else entirely. Communication networks, electromagnetic signaling, environmental monitoring. We don't know. What we do know is that cities invested enormous resources into building infrastructure that was far more complex and interconnected than simple street lighting require. They integrated this infrastructure into their architecture at every level, from lampposts to church spires. They follow geometric and mathematical principles that suggest sophisticated planning. And then they stopped talking about it, replaced it all with conventional electrical systems, and acted like the old system never had any special purpose at all. Next time you're walking through an old city, look at the relationship between the lampposts and the buildings around them. Notice how they're positioned. Notice the metal elements on the rooftops. Notice how everything seems to be pointing at something or arranged in patterns. You're looking at the physical remains of a system that someone worked very hard to make us forget. The infrastructure is still there. The buildings still have their spires and domes and finials. The lampposts still stand on their deep foundations. We just don't remember what it was all for. And maybe that's exactly how someone wanted it. So we've established that these lampposts were overbuilt, overcomplex, and positioned according to some mysterious geometric system that nobody wants to explain. But here's where things get truly bizarre. The metal itself is wrong. And by wrong, I mean, this shouldn't exist yet, according to our understanding of metallurgical history, wrong. When modern materials scientists have actually bothered to analyze surviving specimens from these 19th century lampposts, they've found alloy compositions and manufacturing techniques that officially shouldn't have been possible in that era. It's like finding a smartphone in a Viking burial mound. The object exists, it's real, but it shouldn't be there according to the timeline we've all agreed upon. Let's talk about what cast iron is supposed to be. In the mid-1800s, cast iron was a relatively simple material. You take iron ore, smelt it in a blast furnace, and you get iron with a carbon content somewhere between 2 and 4%. That's it, basic stuff. The composition varied depending on the ore quality and smelting process, but it was all pretty straightforward. Different foundries would have slightly different impurities based on their local ore sources, which is actually how modern metallurgists can often trace where a piece was manufactured. It's like a chemical fingerprint. Each region had characteristic trace elements in their iron. But these lampposts? They're not playing by those rules. Chemical analysis of specimens from various cities has revealed alloy compositions that are way too sophisticated for standard mid-19th century production. We're talking about carefully controlled carbon percentages, specific additions of other elements in precise ratios, and trace element profiles that don't match any known foundry signatures from that period. It's like someone was following a recipe that shouldn't have been written yet. Here's a specific example. In 2007, a materials science lab in Germany analyzed sections from several lampposts that were being removed during a street renovation in Berlin. These lamps dated to the 1850s based on municipal records and stylistic analysis. The metallurgical testing showed iron with controlled additions of silicon, manganese, and chromium in specific percentages. Now, here's the problem. Chromium wasn't regularly added to iron alloys until the development of stainless steel in the early 1900s. Manganese was used occasionally in the 19th century, but usually as an accidental contaminant, not a deliberate addition in controlled amounts. Silicon additions became standardized in the late 1800s. But here we have all three elements present in an 1850s casting, in percentages that suggest intentional alloying, not random contamination. The lab report basically concluded with a polite version of, "We don't know how this is possible." The composition was described as anomalous for the period and inconsistent with known foundry practices, which is science speak for, "This is weird, and we can't explain it, but we're not going to say that loudly because it makes us sound like we don't know what we're doing." Similar results have popped up in other analyses. A university in London examined lamppost fragments from the 1860s and found alloy compositions with trace elements that shouldn't have been there. Tiny amounts of nickel, molybdenum, and vanadium. These aren't elements that just randomly show up in iron ore. They have to be deliberately added, or they come from very specific ore sources that weren't being used for street lamp manufacturing. The concentrations were low, just a few tenths of a percent, but they were consistent across multiple samples from different lamps in different parts of the city. That's not random contamination. That's a manufacturing specification. The casting quality is another red flag. When you examine the microstructure of these old lamppost metals under a microscope, you see grain structures and crystalline formations that indicate very controlled cooling processes. Modern metallurgists know that cooling rate affects final material properties. Cool too fast and you get brittle material. Too slow and you get weak material. Getting it just right requires careful process control. The lampposts show evidence of controlled cooling that produced optimal grain structures for strength and durability. This level of process control was theoretically possible in the mid-1800s, but it required expensive furnaces, skilled operators, and quality control procedures that most foundries of that era couldn't afford. Yet here it is, showing up in simple street lamps across multiple cities. Some specimens show evidence of surface treatments that are historically problematic. Coating layers that shouldn't exist with the technology of the time. Corrosion-resistant surfaces applied using processes that weren't supposed to be invented yet. There's a lamppost in St. Petersburg that has a coating on its interior surface that modern analysts describe as similar to modern galvanization but with a composition that doesn't match any known 19th century process. The coating is still there, still intact after 150-plus years, doing its job of preventing corrosion. But nobody can figure out how it was applied or what exactly it's made of. The copper finials and decorative elements have their own mysteries. Copper is straightforward, right? It's an element, you can't really mess with its composition. Except when you start looking at the copper used in these lamp installations, you find that it's unusually pure. Modern electrical-grade copper is 99.9% or higher purity, because impurities reduce conductivity. In the mid-1800s, copper was typically much less pure. 98% was considered good quality. But the copper from these lamp finials often tests at 99.5% purity or higher. That level of refinement was expensive and usually reserved for specialized applications, not decorative street lamp components. Unless, of course, those components needed high electrical conductivity for some reason. There are also these weird working marks on some specimens. Tool marks and manufacturing traces that don't match known period techniques. Some lampposts show evidence of precision machining that would have required lathes and mills with capabilities that weren't standard in the 1850s and 1860s. Thread cutting that's more accurate than should have been possible with available equipment. Surface finishes that suggest grinding and polishing to tolerances that were typically only achieved decades later. It's like someone had access to better tools than the era officially provided. The brass used in many decorative elements shows similar anomalies. Brass is a copper-zinc alloy, and the ratio of copper to zinc affects the properties and color of the final material. Historical brass from the 19th century typically shows inconsistent composition because controlling the zinc content during casting was difficult. Zinc vaporizes easily, so you'd lose some during the melt, making it hard to hit precise ratios. But the brass components from these lamp installations show remarkably consistent composition across multiple specimens. Someone had figured out how to control the alloying process with precision that shouldn't have been routine yet. Here's where it gets really fun. Some researchers have tried to replicate the manufacturing techniques using period-accurate equipment and methods. The results? They can get close but not quite match the quality. Modern metallurgists, with all their knowledge and experience, using reconstructed 19th century furnaces and tools, can produce castings that are similar but not identical to the originals. There's something about the original process that we're missing. Either they had techniques that weren't documented, or they had equipment that was more sophisticated than historians believe, or there's some other factor we haven't identified. The durability of these materials is also suspicious. These lampposts have been sitting outside, exposed to weather, pollution, temperature swings, and everything else the environment can throw at them, for 150-plus years. And many of them are still in remarkably good condition. The metal hasn't rusted through. The structure hasn't failed. The materials have held up far better than period-equivalent iron should have. Compare them to other cast iron structures from the same era. Railings, gates, brackets, and the lampposts consistently show superior corrosion resistance and structural integrity. They were built to last in ways that suggest someone expected them to remain functional for a very long time. There's also evidence of non-destructive testing that shouldn't have been possible. Some lampposts, when examined closely, show subtle surface marks that look like inspection markings, small stamps, scratches, or paint marks in specific patterns. Modern quality control uses similar marking systems to track tested components and indicate pass-fail status. But this level of systematic quality inspection wasn't standard practice in the 19th century, especially not for municipal infrastructure. Yet here it is. suggesting that someone was checking these lamps to make sure they met specific standards. Standards that apparently involved material properties and manufacturing quality beyond what simple gas lamps would require. The lead content in some specimens is interesting too. Modern regulations restrict lead in materials because of health concerns, but in the 19th century, lead was commonly added to various alloys to improve casting properties. Except these lampposts often have very low lead content, or none at all. Someone was deliberately avoiding lead additions, which would have made the casting process more difficult, but resulted in healthier and more durable material. This suggests manufacturing priorities that don't align with typical 19th century cost-cutting industrial practices. Now let's talk about the cover-up. And yes, I'm using that word deliberately, because what happened to these lamp systems in the late 1800s and early 1900s wasn't just replacement or modernization, it was systematic erasure. Cities around the world, in a remarkably synchronized fashion, didn't just swap out old lamps for new ones. They dismantled everything, removed all traces, destroyed the records, and acted like the old system never had any special significance. This is the part where the conspiracy stops being theoretical and becomes documented historical fact, because all of this is in the archives if you bother to look. The timeline is suspiciously consistent. Starting roughly in the 1880s and accelerating through the 1890s and early 1900s, cities across multiple continents began what they called modernization programs for their street lighting. But these programs were weirdly thorough. They didn't just remove the visible lampposts. They excavated the entire foundation structures, filled in the underground chambers, cut the buried cable channels, and removed every trace of the underground infrastructure we talked about earlier. This is way beyond what you'd need to do to install new electric lamps. You could just unbolt the old lamp, bolt on the new one, and be done in an afternoon. But no, they were digging down meters, removing structures that were completely underground and not interfering with anything, and spending massive amounts of money to erase infrastructure that wasn't bothering anyone. Paris is a great example. In the 1890s, the city launched a comprehensive street lighting modernization project. The official stated purpose was to replace old gas lamps with new electric lighting. Sounds reasonable, right? Except the budget for this project was enormous, far exceeding what lamp replacement should cost. And the work descriptions in city contracts specifically mention complete removal of existing underground structures and filling and sealing of subterranean chambers. Why? If you're just changing the lamps, why remove foundations that are 5 meters underground? The new electric lamps could have used completely separate, shallow foundations. But someone wanted those old underground structures gone. Deliberately gone. New York had a similar experience. Starting in the 1890s, the city began replacing its elaborate old lamp systems with Edison's new electric lights. Again, the scope of work went far beyond simple lamp replacement. City records show contracts for excavation and removal of existing lamp foundations to depths of 15 feet or more, and demolition of underground utility chambers. The costs were substantial, and multiple city council members at the time questioned why so much money was being spent on removing infrastructure that was already built and could have been left in place without causing problems. The responses from the Public Works Department were basically, it's necessary for the new system. Except it wasn't. The new electric lamps used completely different mounting systems and didn't need the old foundations removed. London, Berlin, St. Petersburg, the pattern repeats. In every major city that had elaborate 19th century lamp systems, there was a synchronized push in the 1890s and early 1900s to not just replace but completely erase the old infrastructure. And the timing corresponds exactly with the rise of centralized electrical power systems and the formation of major electrical utility companies. Thomas Edison founded his electric company in the 1880s. George Westinghouse and others followed. By the 1890s, there was a major push to establish electrical monopolies in major cities. And wherever these new electrical companies gained control, the old lamp systems were systematically dismantled. Here's where it gets interesting from a business perspective. The companies pushing electric lighting stood to make enormous profits from centralized power generation and distribution. If you control the power supply, you control the money. Customers have to pay you for electricity every month, forever. It's a beautiful business model, a subscription service before subscriptions were a thing. But this business model only works if there's no alternative. If there's some other way to light streets that doesn't require paying a utility company, that's a problem. That's competition you need to eliminate. Now, I'm not saying the old lamp system was providing free energy or anything quite that revolutionary. But what if it was more efficient? What if it required less maintenance? What if it used some method of power distribution that didn't require burning coal or oil? Any of those scenarios would threaten the profitability of the emerging electrical utility monopolies. And if you're a business looking at potential competition, you don't just beat it, you erase it. You make sure nobody can even remember it existed so they can't go back to it. The archive destruction is particularly damning. Multiple cities experienced accidental fires or routine purges of old municipal records during this exact time period. Paris lost substantial street lighting archives in an 1894 fire at a city records building. New York had a records purge in 1897, where obsolete technical documents were destroyed to make room in storage. London experienced similar losses. These might be coincidences, but they're awfully convenient coincidences. The kinds of records that would have detailed how the old lamp systems actually worked, technical specifications, installation diagrams, maintenance procedures, underground infrastructure layouts, those are exactly the records that seem to have disappeared. What survives in the archives is also telling. The remaining documents are remarkably vague about the technical details of the old lamp systems. Lots of information about costs, contracts, and administrative procedures. Very little about how the lamps actually functioned. It's like someone went through and removed anything that would let future researchers understand what the system really was. What remains is the bureaucratic shell with the technical guts carefully extracted. There are newspaper accounts from this era that are fascinating to read with modern eyes. Articles about the transition from old lamps to electric lights often include quotes from city officials or utility company representatives, making arguments about why the old system needed to be completely replaced, rather than upgraded. The arguments always emphasize the need for modern technology and progress, but they're weirdly insistent about not preserving or adapting any part of the old infrastructure. It's like they're trying really hard to convince everyone that nothing from the old system is worth keeping. Some newspapers published letters from citizens questioning why so much money was being spent on removal rather than adaptation. These letters point out that the old lampposts were structurally sound, the underground work was already done, and adapting the existing infrastructure would be cheaper than starting over. The responses from officials are defensive and dismissive. The old system is obsolete and incompatible with modern requirements, was a common refrain. But nobody ever explained exactly what made it incompatible. Incompatible how? The new electric lamps could mount on the same poles. They could use the same spacing. What specific incompatibility required complete removal? The labor involved in this erasure was substantial. Cities hired specialized crews for the dismantling work. Not just regular construction workers, but teams that were specifically trained or supervised for removing the old lamp infrastructure. There are accounts of these crews working under close supervision, with inspectors present to ensure everything was removed completely. This is unusual for routine infrastructure work. You don't typically need that level of oversight for demolition. Unless you're making sure nothing is preserved, nothing is examined too closely, and nothing is documented for future reference. The timing also correlates with something else interesting: the establishment of electrical engineering as a formal profession. In the 1880s and 1890s, universities started offering degrees in electrical engineering. Professional societies like the Institute of Electrical Engineers were founded. Standards bodies began codifying practices. This institutional framework created a new class of experts whose authority was based on the premise that they understood the new electrical technology better than anyone else. But this authority would be undermined if there was evidence that previous generations had accomplished similar or better results using different methods. The professional credibility of this emerging field depended on the narrative that they were pioneering new territory, not rediscovering old knowledge. Corporate consolidation played a role too. By the early 1900s, the electrical utilities were merging and being bought up by larger companies. General Electric, formed from the merger of Edison's companies with others, became a dominant force. These corporations had every incentive to eliminate evidence of alternatives to their centralized power model. They lobbied governments, funded research, shaped engineering education, and generally worked to ensure that centralized grid-based electrical distribution was seen as the only viable approach. Any infrastructure or technology that suggested other possibilities needed to be forgotten. The international coordination is the most suspicious aspect. This wasn't one city or one country deciding to modernize their lighting. It was a global movement, happening simultaneously across Europe, North America, and other developed regions. Cities that had minimal direct communication with each other were following remarkably similar playbooks. Remove the old system completely, destroy the technical records, install the new centralized electric system, and don't preserve anything from before. That level of coordination suggests organized effort by entities with international reach, most likely the emerging electrical industry and associated financial interests. There were holdouts and resistance, but they got steamrolled. Some cities or neighborhoods tried to keep their old lamp systems, arguing they worked fine and didn't need replacement. These efforts were consistently overruled by higher authorities or overcome through political pressure. Permits denied. Maintenance contracts canceled. Insurance requirements changed to make the old systems expensive to operate. Every bureaucratic tool available was used to force adoption of the new electric systems and elimination of the old infrastructure. By the 1920s, it was essentially complete. The old lamp systems were gone. The underground infrastructure was sealed or destroyed. The technical knowledge was lost, and a new generation had grown up assuming electric grid lighting was the only way it had ever been done. The cover-up worked. We forgot there was anything to cover up. And that's exactly what someone planned. The question is, who planned it? Was it spontaneous convergence of business interests acting independently toward the same goal? Was there actual coordination by industry groups or financial powers? We don't have the smoking gun documents that would prove conspiracy versus coincidental alignment of interests. What we have is the pattern. Synchronized worldwide effort to erase a technology and its infrastructure. Massive financial investment in that erasure. Destruction of records that would explain what was being erased, and establishment of a new system that conveniently enriched those doing the erasing. Draw your own conclusions, but the pattern is clear. The old lamps are mostly gone now. The underground chambers are sealed or filled. The archives are gutted. The knowledge is lost. And the only reason we can even piece this story together is because the erasure wasn't quite complete. A few lamps survived. Some underground structures weren't fully destroyed. Occasional documents escaped the purges, and physical evidence in the form of materials and structures can still be analyzed. We're looking at the fragments of something bigger, trying to reconstruct what was deliberately taken apart. And the mere fact that it was deliberately taken apart tells you it was something worth hiding. All right, so we've established that something weird was happening with these lamp systems. They were systematically destroyed, and somebody really didn't want us asking questions. But here's the thing everyone wants to know. If these weren't just gas lamps, what were they actually doing? How could they possibly work without being plugged into anything? Well, buckle up, because we're about to dive into the science that 19th century researchers were exploring before it mysteriously got shelved. And by shelved, I mean buried, forgotten, and replaced with systems that conveniently required you to pay a monthly bill. Let's start with atmospheric electricity, which is exactly what it sounds like. Electricity that exists in the air around us. This isn't pseudoscience or wishful thinking. The atmosphere is literally charged with electrical potential. Benjamin Franklin figured this out in the 1750s with his famous kite experiment, which was either brilliantly insightful or suicidally reckless depending on how you look at it. The point is, the air around us carries electrical charge, and scientists in the 19th century knew this. They weren't just aware of it, they were actively trying to figure out how to use it. The Earth itself is a giant electrical system. The planet has a negative charge on its surface and a positive charge in the upper atmosphere, creating a voltage gradient of roughly 100 to 300 volts per meter of altitude. That means if you stick a metal pole 10 meters in the air, there's a 1,000-volt potential difference between the top and the ground. Now you can't draw much current from this. It's high voltage but low amperage, like a static electricity shock from a doorknob. But 19th century researchers were investigating whether you could accumulate this charge, store it, or use it directly for certain applications. And surprise, surprise, they were having some success with it. There's a guy named Lord Kelvin, actual title, actual brilliant scientist, who invented something called a water dropper electrostatic generator in the 1860s. This device could generate high voltage by exploiting the natural charge separation in falling water droplets. It worked. It was reproducible. And it demonstrated that you could extract usable electrical charge from environmental processes without burning any fuel. Kelvin was a respected mainstream scientist, not some fringe crackpot. And he was proving that environmental energy harvesting was possible. Then there's the work on telluric currents, naturally occurring electrical currents that flow through the Earth's crust. These were discovered in the early 1800s and were well documented by mid-century. Telegraph operators noticed that their lines would sometimes carry current even when no battery was connected. The Earth itself was generating electrical flow. Researchers investigated whether these currents could be tapped for useful work. The answer was complicated. Telluric currents are variable and unpredictable, flowing stronger during solar activity and geomagnetic storms. But they're real, and they can be detected and measured. Here's where it gets interesting for our lamp mystery. A properly grounded metal structure extending both upward into the air and downward into the Earth could theoretically act as an antenna or collector for both atmospheric electrical potential and telluric currents. If you had a network of these structures positioned according to specific geometric principles to maximize resonance and collection efficiency, you might be able to accumulate enough charge to do something useful, like, say, power lights. Not constantly, maybe not reliably by modern standards, but enough to provide illumination under the right conditions. This brings us to Nikola Tesla, who historians love to portray as a lone genius working in isolation. Except he wasn't working in isolation. He was building on decades of research by others into atmospheric electricity and wireless energy transmission. Tesla's famous Colorado Springs experiments in 1899 involved sending electrical current through the Earth and receiving it at a distance without wires. He demonstrated that you could transmit power wirelessly using the Earth itself as part of the circuit. His proposed Wardenclyffe Tower project was designed to broadcast electrical power globally using atmospheric and telluric electrical phenomena. But here's the critical detail. Tesla started his major work on wireless power in the 1890s and early 1900s. Our mysterious lamp systems were installed in the 1840s through 1870s. That's 30 to 50 years earlier. Either Tesla was rediscovering principles that were already known and implemented, or there was parallel development happening that never made it into the official history books. Given everything we've seen about how thoroughly the old lamp systems were erased, the second option seems entirely possible. The Schumann resonance is another piece of this puzzle. In the 1950s, physicist Winfried Schumann predicted and then confirmed that the Earth's surface and the ionosphere form a cavity that resonates at specific frequencies, primarily around 7.83 Hz. This resonance is caused by lightning strikes around the globe, creating electromagnetic waves that circle the Earth. Here's the thing. You don't need to understand the math to observe the effects. Researchers in the 19th century were documenting electromagnetic phenomena without having Schumann's theoretical framework. They knew something was happening. They knew there were global electromagnetic patterns. They just described it differently. If you wanted to design a system to tap into these natural electromagnetic resonances, what would it look like? You'd want tall metal structures with good conductivity, grounded deeply into the Earth, positioned in geometric arrays that maximize collection and resonance effects. You'd want the system distributed across a wide area to average out local variations. You'd want specific spacing between elements to create standing wave patterns. Does this sound familiar? Because it sounds exactly like the lamp system we've been examining. Now, let's talk about why this research got shut down. In the 1880s and 1890s, the electrical industry was taking shape. Thomas Edison, George Westinghouse, and others were building centralized power generation systems. Coal-fired power plants producing electricity that was transmitted through wires to customers who paid for the service. This was a great business model. Reliable, controllable, and most importantly, monetizable. You own the generators, you own the transmission lines, customers have to pay you, and they have no alternatives. It's a utility monopoly's dream. But what if there was an alternative? What if you could collect electrical energy from the environment? What if power could be harvested from atmospheric and telluric sources without burning fuel? Even if such a system was less reliable or less powerful than a coal plant, it would be competition. It would be an alternative that people might choose, especially if it was cheaper or more accessible. And competition is bad for monopolies. This is where the money comes in. The late 19th and early 20th centuries saw massive capital investment in electrical infrastructure. J.P. Morgan and other financiers poured millions into electrical utilities. They did this expecting returns, long-term, stable returns from customers paying monthly bills for electricity. But those returns depend on having no competition. If someone proves you can light your home by putting up a tall copper pole in your backyard that collects atmospheric electricity, suddenly your multi-million-dollar coal power plant investment looks a lot less secure. There's a famous story about Tesla trying to get funding from J.P. Morgan for his wireless power transmission project. Morgan initially invested, but then pulled funding once he realized the system couldn't be metered. There was no way to charge customers for how much power they used if the power was being broadcast freely through the air. Morgan reportedly asked Tesla, "If anyone can tap into the power without paying, where do we put the meter?" Tesla had no good answer. The project died. Not because it wouldn't work, but because it wouldn't make money for the right people. This pattern repeats throughout the history of alternative energy research. Promising technologies that might provide cheap or free energy get funded initially, then hit a wall when investors realize they can't control or monetize the energy source. Research gets defunded, patents get bought up and shelved, scientists get redirected to other projects. The technology doesn't disappear because it's impossible. It disappears because it's unprofitable. The scientific journals from the late 1800s show this shift happening in real time. Papers on atmospheric electricity and environmental energy harvesting were common in the 1860s and 1870s. By the 1890s and early 1900s, they're becoming rare. By the 1920s, they've basically stopped. The research community moved away from these topics not because they were solved or proven impossible, but because the funding dried up and the professional incentive structure changed. If you wanted to have a career in electrical engineering, you studied grid-based power systems, not atmospheric energy collection. There are also patents from this era describing devices for collecting atmospheric and telluric electricity. Lots of them. Some are obvious nonsense from hopeful inventors who didn't understand what they were doing, but others are technically sophisticated, filed by credentialed scientists, with detailed specifications that suggest real experiments and real results. These patents exist in the records, but they're never mentioned in standard electrical engineering history. They've been quietly forgotten, along with the research that backed them up. Here's the really cynical part. The electrical utility companies actively worked to suppress alternative energy research, not just by withdrawing funding, but by lobbying governments, shaping educational curricula, and controlling professional organizations. If you graduated from an electrical engineering program after 1900, you were taught that centralized generation and grid distribution was the only serious approach to electrical power. Alternative methods weren't even presented as failed experiments. They simply weren't mentioned at all. The next generation of engineers literally didn't know there had been alternatives, so they never questioned the monopoly system they inherited. The oil and coal industries also had every reason to ensure that alternative energy research stayed dead. If electricity comes from atmospheric sources, you're not burning coal. If it comes from environmental collection, you're not buying fuel. These industries were making enormous profits from providing the energy that powered the electrical grid. Alternative energy systems threatened that revenue stream, so they invested in making sure those alternatives never became viable competitors. This isn't ancient history. The same pattern continues today. When new energy technologies threaten existing power structures, they face resistance not from physics, but from economics and politics. Battery technology that might enable local energy storage and independence from the grid? Suddenly, there are regulatory barriers. Solar panels that let homeowners generate their own power? Utility companies lobby for fees and connection charges that reduce the economic benefit. The game hasn't changed, just the players and the technologies. Now let's get geometric, because this is where we stop talking about theories and start looking at cold, hard, mappable evidence. Pull up old city maps from major 19th century urban centers and plot the locations of street lamps from that era. Not just vaguely, plot them precisely with coordinates. Then sit back and watch as patterns emerge that have nothing to do with efficient lighting and everything to do with geometric design principles that suggest a completely different purpose. Welcome to Cities as Machines, where every street and every square was a functional component in a system we've forgotten how to read. Let's start simple. In a purely functional street lighting system, you'd space lamps based on illumination needs. You put them closer together on busy streets, farther apart on quiet residential roads, and you'd cluster them around important buildings or intersections where people need better visibility. The spacing would be irregular, adapted to the specific needs of each location, right? Wrong. That's not what we see in 19th century lamp placement. What we see is regular geometric grids, consistent spacing regardless of function, and arrangements that create specific patterns when viewed from above. Paris is Exhibit A. The Haussmann renovations of the 1850s and 1860s completely redesigned central Paris, and part of that redesign was a comprehensive street lighting plan. When you map the lamp positions from that era, they form an almost perfect rectangular grid across large swaths of the city. The spacing is remarkably consistent, roughly 40 meters between lamps, regardless of street width, traffic density, or building types. This is not adaptive design. This is template implementation. Someone decided that lamps would go in these exact positions according to a geometric plan, and practical lighting needs were secondary considerations at best. Look closer, and you'll see more complex patterns. Major intersections often have lamp arrangements that create star patterns, 5 or 6 lamps positioned around a central point at equal angles. Public squares have lamp arrangements that form circles or polygons. Important buildings are often surrounded by lamp positions that create geometric frames. These aren't random decorative choices. These are intentional geometric constructions that suggest the lamp network was designed according to mathematical principles, not lighting requirements. Berlin shows similar patterns. The city's expansion in the late 19th century included systematic street lamp installation, and the positions form grid patterns aligned with cardinal directions. Not approximately aligned, precisely aligned, as if someone was using a compass and protractor to mark lamp positions. Certain major boulevards have lamps that create parallel lines extending across multiple city blocks, perfectly straight, perfectly spaced. The geometric precision is impressive. It's also completely unnecessary if you're just trying to light streets. London's lamp network has its own peculiarities. The City of London, the historic core, has lamp arrangements that follow medieval street patterns, but with geometric regularities that don't match the irregular street layout. It's like someone overlaid a geometric template on top of the existing street network and positioned lamps according to that template, regardless of where streets actually ran. Some lamps end up in odd positions, in the middle of small courtyards, at seemingly random points along building facades, but when you plot them all, they align with grid lines or geometric shapes that span the district. New York's grid system makes the patterns even more obvious. Manhattan's street layout is already a grid, so positioning lamps in geometric patterns was easier, and boy, did they do it. Lamp positions from the 1860s and 1870s create not just simple grids, but nested geometric patterns. Squares within squares, diagonal alignments that create X patterns at major intersections, and regular spacing that's mathematically precise across dozens of city blocks. The consistency is what stands out. Every lamp is exactly where the geometric formula says it should be. Here's where it gets weird. When you overlay these historical lamp position maps on modern electrical transmission line maps, they correlate. Not perfectly, but way more than chance would predict. Major electrical substations today are often located at or near positions that were major nodes in the old lamp networks. High-voltage transmission lines frequently run along routes that had the highest density of old lamp installations. It's like the modern electrical grid was built on top of a template that already existed in the 19th century lamp network. Did city planners in the 20th century independently choose optimal locations that happened to match the old patterns? Or did they recognize that the old lamp positions marked something significant and build on top of that foundation? The geometric patterns show up in multiple scales. At the neighborhood level, lamps form regular grids. At the district level, major lamp clusters create larger geometric shapes, triangles, hexagrams, radial patterns. At the city level, the entire lamp network creates metropolitan-scale geometry that can only be seen when you zoom out and look at the whole thing at once. This is hierarchical design, systems within systems, each level following geometric principles, all integrated into a unified whole. This is not how you design street lighting. This is how you design communication networks or power distribution systems. Certain geometric shapes show up repeatedly across different cities. Hexagonal patterns are common, arrangements of 6 lamps around a central point, or 3 pairs of lamps forming a hexagon. Star patterns with 5 or 6 points appear at major intersections. Spiral arrangements show up in public squares and around important buildings. These aren't universal cultural symbols that just randomly appeared in street lamp placement. These are specific geometric configurations that have mathematical properties related to resonance, standing waves, and electromagnetic field patterns. There's also consistent alignment with astronomical or geomagnetic features. Some city lamp networks have major axes aligned with true north-south or east-west directions. Others align with magnetic north, which is different from true north and varies by location. A few show alignments with solar orientations, lines of lamps that point towards sunrise on the equinoxes, for example. This kind of alignment suggests the designers were paying attention to Earth's magnetic field and solar position, which would matter for atmospheric electrical collection, but not for lighting streets. The spacing ratios are mathematically significant too. The standard 40-meter spacing I mentioned earlier isn't random. It's a wavelength. Specifically, it's close to wavelengths associated with certain radio frequencies and electromagnetic resonances. If you were designing a system to capture or transmit electromagnetic energy at specific frequencies, 40-meter spacing between elements would make sense. If you're just lighting streets, any spacing between about 20 and 60 meters would work fine. There's no practical reason to be so precise about 40 meters specifically. Some researchers have analyzed these patterns using modern network topology mathematics, and the results are fascinating. The old lamp networks show characteristics of optimized distribution systems, minimum spanning trees, load balancing architectures, redundant pathways. These are concepts from modern electrical engineering and computer networking. But the lamp networks exhibit these properties, suggesting they were designed with similar optimization principles in mind. Either 19th century city planners were accidentally stumbling onto advanced network design concepts, or they were deliberately designing a distributed system with those properties. There are also fractal-like properties in some lamp network patterns. Fractal geometry, where patterns repeat at different scales, is a relatively recent mathematical framework, but natural systems exhibit fractal properties all the time. Some city lamp networks show fractal-like repetition, similar geometric patterns at the neighborhood scale, district scale, and metropolitan scale. This is how you design a system that needs to function consistently across different scales, collecting or distributing energy efficiently, regardless of whether you're looking at a single block or an entire city. When urban renewal projects demolished old neighborhoods and rebuilt with modern street layouts, the new lamp positions often ended up in different geometric arrangements than the old ones, and the lighting actually got worse in some cases. There are documented examples of neighborhoods where residents complained that the new lighting didn't work as well as the old system, despite the new lamps being electrically brighter. Maybe the old positions had been optimized for something other than direct illumination. Maybe they were positioned to create field effects or resonance patterns that enhanced illumination indirectly. We don't know, because we've lost the technical knowledge of what those systems were actually designed to do. The bottom line is this: cities weren't just places to live, they were engineered systems. The lamp networks were part of that engineering, designed according to geometric and mathematical principles that served purposes beyond simple illumination. Every street, every square, every lamp position was part of a larger machine. We can still see the machine's structure in old maps and surviving infrastructure. We just can't remember what the machine was supposed to do. And that's exactly the amnesia that someone worked very hard to create. Next time you look at an old city map, don't just see streets and buildings. Look for the patterns. Look for the geometric arrangements. Look for the mathematical precision hiding in plain sight. Because once you see it, you can't unsee it. And you start asking questions about what else might be hidden in our cities, forgotten but not gone, waiting for someone to remember what it all meant. So you've made it this far, and you're probably thinking, okay, this is all fascinating and terrifying, but can I actually see any of this for myself? The answer is absolutely yes. Despite the systematic cover-up, despite the deliberate erasure, despite someone's best efforts to memory hole this entire chapter of technological history, pieces of the puzzle are still out there. You just need to know where to look and what you're looking at. Consider this your treasure map, except instead of gold, you're hunting for evidence that our entire understanding of 19th century technology might be incomplete, which is honestly way cooler than gold. Let's start with the easiest hunting ground: historic European city centers. These are your best bets because European cities tend to preserve old infrastructure longer than American cities, which have a habit of tearing everything down and rebuilding every few decades like we're playing SimCity on Fast Forward. In Paris, the Marais district and the Latin Quarter still have some original lampposts from the 1860s and 1870s. Not many, but they're there. Look for cast iron poles with elaborate decorative elements, copper or brass finials on top, and that characteristic overbuilt construction we've been discussing. The giveaway is the base. If it's original, it'll be massive, way thicker than modern lamp bases, often with visible bolt patterns that suggest serious underground attachment. The trick is distinguishing between original 19th century lamps and later reproductions. Cities love putting up antique-style lamps that look old, but are actually modern fabrications. Here's how to tell the difference. Original lamps have weathering patterns that modern manufacturing can't replicate. Look for corrosion that's 150 years deep, not surface-level aging. Check the casting quality. Originals have slight imperfections and asymmetries that mass production tries to eliminate. Most importantly, look at the internal structure if you can see it. Originals have those complex multi-chamber interiors and ventilation systems we discussed. Reproductions are just hollow tubes because they're actually meant to be simple lamps, not mysterious electromagnetic collectors or whatever the old ones really were. London is another gold mine, particularly in the City of London, the historic square mile that's the original core. Westminster and areas around the Thames embankment have surviving examples. Some are still functional, retrofitted with modern electrical components, but retaining the original posts and structures. Look for lamps with the British Royal cipher or municipal markings that date to the Victorian era. If you see VR, Victoria Regina, cast into the base, congratulations, you're looking at something from the 1840s through 1901. Those are the real deal. Berlin is trickier because World War II destroyed a lot of infrastructure, but some districts like Charlottenburg and parts of Mitte still have examples. German engineering being what it is, these lamps were built to survive apocalypse, and in some cases, they literally did. Look for lamps with Prussian eagles or municipal coat of arms cast into the base. German originals tend to be even more overbuilt than French or British examples, with walls so thick you wonder if they were expecting the lampposts to double as bomb shelters. St. Petersburg is fascinating because Russian infrastructure preservation is chaotic. Some stuff gets meticulously maintained. Other stuff gets completely ignored and left to rust. The city center, particularly around Nevsky Prospect and the historic districts, has original lamps from the 1850s through 1880s. Russian examples often feature more elaborate copperwork on top, with multiple tiers and complex geometric patterns. The Orthodox Church influence means you'll see 8-pointed star patterns frequently. Officially, these are religious symbols, but they also happen to be excellent geometric configurations for electromagnetic resonance. Coincidence? At this point, I'm not sure I believe in coincidences anymore. American cities are harder because they did a much more thorough job of removing the old systems. But there are survivors. New Orleans is your best bet in the U.S. The French Quarter has some original lampposts, and because New Orleans does everything at its own pace, they never got around to removing all the underground infrastructure. There are documented cases of construction projects in the French Quarter hitting old lamp foundations and underground chambers that were sealed in the early 1900s. Boston's Beacon Hill neighborhood has a few examples, though many have been modified beyond recognition. Philadelphia's Old City District has some survivors tucked away on side streets where modernization programs apparently ran out of budget. San Francisco is interesting because the 1906 earthquake and fire destroyed a lot, but some infrastructure survived and was just built over. There are areas of the city where you can see old lampposts that are clearly pre-earthquake based on construction style, and there are persistent rumors among urban explorers about underground chambers and sealed tunnels that might be remnants of the old lamp infrastructure. San Francisco also has good municipal archives if you want to dig into historical records. The city kept detailed documentation of infrastructure before the earthquake, and some of those records survived. In Asia, cities that were developed during the colonial period sometimes have examples. Shanghai's old colonial districts have lamps from the 1880s and 1890s that show the same construction characteristics: overbuilt bases, copper finials, suspiciously deep foundations. Hong Kong's Central District has some survivors from the same period. Singapore has a few examples in the colonial core. These Asian examples are particularly interesting because they show that the system wasn't just European. It was being deployed globally wherever cities were being developed or modernized in the late 19th century. Now, what should you look for when you find a suspicious old lamppost? First, examine the base. Is it disproportionately large for the pole's height? Are there bolt patterns suggesting a foundation that extends deep underground? Can you see evidence of sealed openings or capped channels that might have connected to underground infrastructure? Second, look at the pole itself. Is it hollow with evidence of internal chambers? Are there vents or holes arranged in geometric patterns? Is the wall thickness obviously excessive for just supporting a light fixture? Third, and this is the big one, look at the top. Is there copper or brass work that seems decorative but follows specific geometric principles? Multiple points arranged symmetrically? Radiating arms or spikes? Spherical elements with protruding features? These are the components that suggest electromagnetic function. Fourth, check the positioning. Is this lamp part of a larger network where positions seem to follow geometric patterns? Are neighboring lamps spaced at consistent intervals? Does the positioning align with significant buildings or urban features in ways that suggest systematic planning? If you want to go full detective mode, Here's advanced stuff to look for. Check municipal archives for historical maps showing original lamp positions. Compare these to modern street layouts. Did they keep the same positions? Are there locations where no lamp exists today, but the street shows evidence of a filled-in foundation or capped underground access? Old photographs can be gold mines too. Find images of the street from the 1870s or 1880s and see what the lamps looked like originally. Has the structure been modified? What elements have been removed or replaced? Talk to local historians and historical societies. Ask about old lamp systems. You'll be surprised how much information exists in local archives that never makes it into academic history books. Municipal engineering departments sometimes have old technical drawings and specifications that were filed away and forgotten. Request access to these archives. They're usually public records, and someone might actually be excited that someone cares about century-old street lamp specifications. Urban exploration communities are another resource, though I have to add the disclaimer that you should respect property laws and safety regulations. But urban explorers often document old infrastructure that most people never see. Underground tunnels, sealed chambers, forgotten utility corridors. They've stumbled across old lamp foundations and underground structures while exploring other sites. Their forums and social media groups can point you to specific locations where remnants of the old system still exist below ground. Here's a fun project you can do from your computer. Use historical map overlays in Google Earth or similar platforms. Take old city maps showing lamp positions and overlay them on current satellite imagery. Look for patterns. Look for alignments. Look for geometric shapes formed by the lamp network. Then compare these to modern infrastructure. Power lines, substations, major buildings. Are there correlations? Are old lamp positions marking locations that later became significant in other ways? For the really dedicated, you can request access to geological survey data or ground-penetrating radar surveys done for construction projects. These sometimes reveal underground structures that weren't officially documented. If a survey shows a large underground chamber or tunnel in a location where historical maps show a lamp post, that's pretty strong evidence that the lamp infrastructure extended underground in ways that the official records don't fully explain. The key thing to remember when you're investigating this stuff, you're not going to find a smoking gun. You're not going to dig up a lamp post with a label saying, "Atmospheric Electricity Collector, manufactured by the Secret Society of Advanced Technology 1867. What you'll find is physical evidence that doesn't match the official explanation. Foundations that are too deep. Construction that's too sophisticated. Materials that are too advanced. Positioning that's too geometric. It's circumstantial evidence, but enough circumstantial evidence starts looking like a pattern. And patterns are how we figure out what actually happened versus what we've been told happened. One more thing, document everything. Take photos, take measurements, take notes. GPS coordinates are your friend. Mark exact positions of interesting lamps or foundation remnants. Create your own database. Share your findings with other researchers. This is distributed investigation. No one person can check every city or examine every surviving structure, but collectively, we can map out what remains of this system and build a more complete picture of what it really was. The evidence is out there. It's hiding in plain sight on city streets, buried under pavement, filed away in dusty archives, and waiting in old photographs. Someone tried to erase it, but erasure is never complete. The physical world is stubborn. Metal lasts. Stone lasts. Underground structures last. And documentation, once created, has a way of surviving even when people try to destroy it. Fragments persist. And fragments are enough to reconstruct the truth if you're patient and persistent enough to collect them. So here we are, at the end of this journey through mystery, cover-up, and historical amnesia. Except we're not really at the end, are we? Because the biggest revelation of this entire investigation isn't any specific fact about street lamps or underground infrastructure or atmospheric electricity. The biggest revelation is that there are things about our past, our relatively recent past, just 150 years ago, that we don't understand and weren't meant to understand. Someone worked very hard to make sure we forgot, and they succeeded so well that most people don't even realize there's anything to remember. Think about that for a moment. We have photographs. We have physical structures still standing. We have municipal records. We have patent filings. We have all this evidence sitting in plain sight. And yet, the official history just glosses over it with vague explanations that don't hold up under scrutiny. They were just fancy gas lamps. Really? Gas lamps with copper crowns optimized for atmospheric conductivity, built on foundations deep enough for a small building, positioned according to geometric principles that create citywide patterns, using materials and manufacturing techniques ahead of their time, all installed simultaneously across multiple continents before global coordination was supposed to be possible. That's not a lamp. That's a system. An elaborate, sophisticated, globally deployed system that did something important enough that someone spent enormous resources to erase all knowledge of what it actually did. What was it really for? I don't know. Nobody knows for certain, because the people who built it are long dead, and they apparently didn't leave clear explanations. Or those explanations were destroyed in the convenient archive fires and document purges of the 1890s. The atmospheric electricity theory makes sense based on the physical evidence and the scientific research happening in that era. The idea that it was an early electrical distribution system that got suppressed by utility monopolies has compelling economic and political logic. Maybe it was something else entirely: a communication network, an environmental monitoring system, an experimental technology that failed and got abandoned. We don't have definitive answers, but here's what we do have: questions. Really good questions. Questions that official history doesn't want to address. Questions like, if cities in the 1850s could deploy sophisticated infrastructure with this level of coordination and technical sophistication, what else were they capable of that we've forgotten? If electrical utility companies had the power to systematically erase evidence of alternative energy technologies, what other inconvenient inventions have been quietly shelved over the decades? If our understanding of 19th century technological capabilities is this incomplete, what other assumptions about history might be wrong? These questions matter because they're not just about the past, they're about now. The same power structures that controlled energy technology in the 1890s still exist today, just with different names and different technologies. The same financial incentives that led to suppression of alternative energy research then still operate now. Understanding how it happened before helps us recognize how it might be happening currently. History doesn't repeat, but it rhymes. And the pattern of powerful interests controlling technological development to maintain their power and profits is a pattern that keeps rhyming across centuries. This is why investigations like this one matter. Not because street lamps are intrinsically important, but because they're a thread you can pull on that unravels larger truths. Every piece of evidence that the official history is incomplete or deliberately misleading is evidence that we should question other official narratives. Every example of systematic cover-up is a reminder that what we know about history is often what powerful people wanted us to know, not necessarily what actually happened. So what do you do with this information? First, you stay curious. Don't accept surface-level explanations for things that seem weird or don't make sense. Dig deeper. Second, you share information. Tell people about this, not to convince them of any specific theory, but to encourage them to ask questions. Third, you investigate yourself. Go look at those old lampposts, visit archives, map patterns, collect evidence. History isn't just something that happened to our ancestors. It's something we reconstruct from evidence, and every person who looks at that evidence with fresh eyes has a chance to see something that previous investigators missed. Fourth, and this is important, don't get so focused on one mystery that you forget there are hundreds of others. The lamp system is fascinating, but it's just one piece of a much larger puzzle about how our technological civilization developed, what paths were taken, what paths were deliberately not taken, and what capabilities we might have lost along the way. Look at old buildings and ask why they're constructed the way they are. Look at historical photographs and ask what they're really showing. Look at patent records and ask what happened to all those inventions that never made it to market. Every answer raises new questions. And finally, maintain healthy skepticism, including skepticism about this investigation. I've laid out evidence and arguments, but I could be wrong about what it means. Maybe there are explanations I haven't considered. Maybe some of the evidence is less significant than it appears. Maybe coincidence really can account for more of this than I'm giving it credit for. Good investigation means being willing to revise your theories when new evidence appears. Don't get so attached to any particular explanation that you ignore contradicting information. What I hope you take away from this isn't a specific belief about street lamps or atmospheric electricity or historical cover-ups. What I hope you take away is an approach. Question everything, demand evidence, follow the physical traces, connect patterns, and never assume that the official explanation is complete just because it's official. The world is weirder and more complicated than any simple narrative suggests. Our history is messier and more interesting than textbooks admit. And there are things hiding in plain sight, all around us, waiting for someone curious enough to notice them and ask, "Wait, that doesn't make sense. What's really going on here?" Your investigation starts now. Every old city has its mysteries. Every historical building has its secrets. Every archive has its forgotten documents. The tools are in your hands: cameras, maps, historical records, analytical thinking. The evidence is out there, scattered across cities and buried in archives, preserved in metal and stone and photographs. Someone tried to erase it, but they failed. Fragments remain. And from fragments, we can reconstruct enough of the truth to realize that what we've been told isn't the whole story. The street lamps are still standing. The underground chambers are still there, sealed but not destroyed. The physical evidence persists because you can't completely erase physical reality. You can only try to make people forget to look at it. But now you know to look. Now you know what you're looking for. And now you're part of the ongoing investigation into what this was really all about. I don't have all the answers. Nobody does. But together we can collect more pieces of the puzzle. We can map more patterns. We can dig up more evidence. We can reconstruct more of the truth. And maybe, just maybe, we can remember what someone worked so hard to make us forget. Because that's the thing about knowledge. Once you realize there's something you don't know, once you see the gaps in the story, once you start asking the right questions, you can't go back to just accepting what you're told. You become a researcher, an investigator. Someone who looks at the world and asks not just what happened, but what really happened. So go out there, look at those lampposts with new eyes, check those maps, visit those archives, document what you find, share your discoveries, ask your questions, and remember, history is not a fixed thing written in textbooks. History is an ongoing investigation, and every one of us is an investigator. The mystery of the street lamps is just the beginning. What you discover next is up to you. Thanks for coming on this journey. Now get out there and find something weird. I'll be waiting to hear what you uncover. And hey, drop a comment letting me know what city you're in and whether you've got any of these mysterious old lampposts in your neighborhood. Let's crowdsource this investigation and see what we can figure out together. History might try to hide its secrets, but we've got curiosity, determination, and the internet. I like our odds.